Page 164, we're going to look at lesson 3.1 on inequalities in their graphs. So basically, inequality is a mathematical sentence uses an inequality symbol to compare the values of two expressions. So there are basically four inequality symbols we'll be talking about. We could have greater than or equal to, greater than, less than or equal to, and less than. Just a reminder to determine what the symbol is, like if I'm just reading those off, that you remember which one is which. Remember, the less than kind of looks like an L for less than, and creatively I think I had a student come up with this one. The greater than symbol, we can kind of make it into a G for greater than. Okay, so those are the symbols, inequality symbols. Inequality means not equal, basically. So problem 1, what inequality represents the verbal expression all real numbers x less than or equal to 7? That would be x is less than or equal to 7. Part B, 6 less than a number k is greater than 13. Be careful with this one. Okay, it's 6 less than a number k. We're actually going to do k minus 6. So you might think about what's 6 less than 10. 6 less than 10 would be 4, right? So you did 10 minus 6. In the same way, we'll do k minus 6 here. So if we look at the got it, what is an inequality that represents these verbal expressions? So A, all real numbers p greater than or equal to 1 5/10. So that would be p is greater than or equal to 1 5/10. And then B, the sum of t and 7 is less than -3. So that would be t plus 7 is less than -3. They're not asking us to solve these or anything. The first one's already solved anyway, but they're just asking us to write those inequalities. So if we look at the next part, it talks about solutions of inequality. So solutions are any number that makes the inequality true. With inequalities, we are going to have multiple solutions, multiple numbers that work. Not like we work out a problem and we get x equals 2. X equals 2, there's only one answer that works. With inequalities, we have a range of answers that are going to work. So if you look at problem 2, they're just asking us for a specific number, if it works or not. So problem 2, is this number a solution of this inequality? So is -3 a solution? So one option is we can substitute -3 in and see if it works. So if we substitute -3 in, we get -6 plus 1, which is -5. Is -5 greater than -3? The answer is no, so it is not a solution. For part B, same idea, they substituted and they got -2 plus 1, which is -1. Is -1 greater than -3? And the answer is yes, and so that is a solution. Depending how many of these they're asking me to do, if they're asking me to do a lot of these, I might be tempted to actually solve it and then graph it on a number line and then determine whether all of these are going to work or not. If there's only 2 of them, it's probably kind of a toss-up, but any more than 2, I would probably just solve it and then compare and see if they work or not. So 2A, right on cue, we've got an inequality, and they're asking us for 4 different numbers, whether they're solutions or not. 4 different numbers, and I'll be getting ahead of myself a little bit here, but with 4 different numbers, I would probably go ahead and just solve it and then see if these numbers work or not. Before we solve this, there's something that we need to mention, kind of a special feature that's going to happen when we solve this inequality. So when you multiply or divide by a negative number, the inequality symbol changes direction. And we did this last year. Just a quick refresher for you kind of why this works rather than me just telling you that this is how it is. For example, 5 is greater than 2. 5 is greater than 2, but if we multiply both sides of this inequality by -1, we get -5 and -2. -5 actually is less than -2. So our inequality sign was greater than, but to make this work, it has to change to less than. So we multiplied by a negative, we had to switch that sign. And then it works the same idea if we're dividing. 5 is greater than 2. If we divide both of those by -1, same thing. We get -5 and -2, and once again, -5 is less than -2. So that's just an example to show you why this actually works with just numbers before we actually do this with variables. So on this problem, if I'm going to solve this, one thing is you can add the opposite here if you want. And then solving these mostly is going to be just like what we would do for solving equations. The only difference is that last step. If we have to multiply or divide by a negative number, then we're going to switch our inequality sign. So first thing for this problem, we're ready to get the variable term by itself, so we could subtract 13 on both sides. So we'd get -7y is less than or equal to -7. So last step then, they're multiplying, so we can divide by -7 on both sides. Dividing by a negative, make sure you remember, if you want to do it right away, that's going to switch your sign when you divide by a negative, because we're dividing by -7 here. And then -7 divided by -7 is 1, so y is greater than or equal to 1. Again, the advantage of doing that is I'm substituting 4 numbers now to see if they work or not. We could graph this on a number line if you want, or you can just then substitute the numbers in at this point and see if they work or not. So if we're trying, the first thing is -1. Is -1 greater than or equal to 1? No. Okay, second one we're trying is 0. Is 0 greater than or equal to 1? No. Is 1 greater than or equal to 1? Or equal to, yes. Is 3 greater than or equal to 1? Yes. And so the nice thing having solved that is now I can just quickly see whether those work or not. So solutions there would be 1 and 3. So when we're doing these, we can also graph these. Rather than graphing these right on the number line, it's easier to tell where your graph is if you graph it above the number line. So like the first one, n is less than 1. Less than 1 means it doesn't include 1, so we'd put an open circle there. And then numbers that are less than 1 would be going to the left. Greater than or equal to 0. It has or equal to, so we'll put a solid circle, a solid dot there. And then greater than would be going to the right. F is greater than -3. Just greater than would be an open circle. Numbers greater than -3 would be to the right. The last one, I would recommend that you switch that around and make the variable be on the left side. If you look at this sign, it opens towards the -2. When we switch it, it's still going to open towards the -2. So that's the same as x is less than or equal to -2. Or equal to, we're going to put a closed circle there at -2. Numbers that are less than that are going to go to the left. One kind of cool thing about these problems that I've discovered in trying to make things easier for you guys to remember also, if the variable's on the left side, if it's on the left side, your inequality symbol and your arrow are going to look the same. Okay, now this one, the last one, you have to switch it around in order for that to work. If you switch it around though, then that works also. Okay, One other thing along the lines of this is there's a thing called interval notation that you will probably be asked to do in high school, so we're going to go ahead and teach that to you guys now as well. Interval notation is a different way of writing our answer rather than graphing it on a number line. And basically, when we do interval notation, we're going to go from the lowest numbers to the highest numbers. So with the interval notation, for example, just going back to that first graph we had, so we had less than -1, or less than 1 rather, less than 1. What we're going to do is think about going from the lowest to the highest on what answers work for this inequality. So there is actually no lowest number that you can come up with here. Whatever number you come up with, I can find something lower than that. So we're going to call this negative infinity. Interval notation, we're going to either be putting parentheses or we're going to put brackets. If we put parentheses, means it doesn't include the point. And we're going to put a bracket if it includes the point. So with infinity and negative infinity, we're always going to do parentheses because we can never quite get to that point. And then we're going to put the highest possible number that could work here. So the highest cutoff on this is that we're at 1. And then the question is just whether we're including that or not, whether we need to put a parenthesis or a bracket there next to the 1. So since it doesn't include the point, it's an open circle here, we're going to put parentheses there. So this would be our interval notation. So parentheses, negative infinity, comma, 1, parentheses would be our interval notation. Same idea, the second one. We had greater than or equal to 0, so we had a closed circle at 0 going to the right. So same thing, start from the left, find the lowest number that works, and then go to the highest number that works. So 0 is the first number that works here, and we actually need a bracket on this because it includes the 0. Since it's a closed circle, it includes 0, so we put a bracket there. Parentheses doesn't include it, bracket includes it. And we're going to infinity or positive infinity. If you want to put a plus sign next to it, you can, you don't have to. And again, since we're never going to technically reach to infinity, we'll put parentheses next to that. So that would be our interval notation for that problem. We look at the next one we graphed. We had f is greater than -3. So from our graph, greater than -3. So furthest to the left, we've got our graph starting at -3. Not quite though, so we're going to put parentheses there because it doesn't include that point. We go up to infinity and we'll put parentheses next to that one. And then one more of those, the last one we did after we switched around and graphed that, we were at -2, closed circle going to the left. So furthest to the left here, we're going towards negative infinity, so we'll put parentheses and negative infinity. And then furthest to the right is -2. It includes -2, so we'll put a bracket next to that. So problem 2, they're asking us to graph this. Like I said, if the variable is on the right side, I would switch this around. This opens towards the 2, so we're going to keep it opening towards the 2. And so that is a is less than or equal to 2, less than or equal to 2. It's going to be a closed circle at 2 going to the left. And again, I'm going to have you graph these above the number line instead of on the number line so we can easily see them. And then You don't have to sharpen your pencil after every problem. It takes quite a bit of shading to make it obvious which way you're going if you put it on the number line. So let's look at the got it problems. We're going to do these graphing them on the number line as well as interval notation. So part A, x is greater than -4. When you do these, at least show me where 0 is and where the number is in comparison to it. It wouldn't take too much to go by ones over there to -4, but greater than -4, greater than doesn't include it, so we put an open circle, and then greater than that would be going to the right. And then for interval notation, so starting from the left, the first thing that we have anything kind of is at -4. Kind of, it's an open circle there, so we'll put parentheses because it doesn't include it. And then we're going over to positive infinity, and then put parentheses next to that one. So for C, or for part B, C is less than 0. So we'd start at 0, open circle though, because it doesn't include it, and less than 0 would be going to the left. And then for interval notation, furthest to the left we go, we keep going to negative infinity, so parentheses negative infinity, and then we're going to 0, not including 0, so we'll put parentheses there also. And part C, I would recommend highly that you switch that around. So it's the same as n is greater than or equal to 3. So it's greater than or equal to 3, so it'd be a closed circle at 3 going to the right. And then interval notation, we're starting at 3, it includes 3, so we put a bracket 3, and then to infinity, parentheses. Problem 4, they're doing kind of the flip here. They're giving us a graph and then saying what is the inequality that would represent that. So you can look at A and B, you can see what that is. We're going to look at the got it for. So got it for part A. So on the first one here, whatever letter you want to pick, X, or if you want to pick something else, it's an open circle there, so that'd be X is less than -3, less than because it's going towards the left, towards the smaller numbers. X is greater than or equal to 0. Greater than or equal to because it's a closed circle at 0. We know it has the or equal to part, and then it's going towards the right, which is towards the bigger numbers, the greater numbers. So problem 5, write inequality that describes the situation. Be sure to define a variable, so that's important. So on A, trail rides starting at $19.99. Slight variation here. I'm going to say let C represent the costs of a trail ride in dollars, and so then C is greater than or equal to $19.99. And then part B, we could say let S represent a legal speed in miles per hour, and so it would be S is less than or equal to 8. If you do an S, depending how you write your 5, I guess most people write the 5s about the same way. I like to do a cursive S because sometimes my 5s are kind of sloppy and they don't really look too much different than my S's. So just a thought. So the concept summary, just kind of going through all that stuff that we just talked about here. Going back real quick on the got it 5, in part B of problem 5, can the speed be all real numbers less than or equal to 8? And the technical answer here actually is no, because the speed can't be negative. So this would be a case, actually, if you were graphing that. We haven't had a situation like this yet. But technically, for the legal speed, 8 would be the maximum, 0 would be the minimum. So we would actually be just in between these two dots. We wouldn't have an arrow on the end. And so this would be actually the first case where if you were doing interval notation, you would have brackets on both ends. Usually we've had a parentheses at least one end or the other because we've always had infinity or negative infinity, but interval notation, it is possible to have brackets on both ends if it's just like this segmented part of the number line. On the lesson check number 2, it's asking whether these are solutions of this inequality. They're asking us for 4 different things here, so I would probably go ahead and just solve the inequality and see if these work or not. So first thing would be add 3 on both sides. And then divide by 6. You might want to change this over. If you divide that out, change it to a mixed number, that would be 2 1/6. So anything greater than or equal to 2 1/6, that's going to work. Greater than or equal to 2 1/6. So -1 is not going to work. 0 is not greater than or equal to 2 1/6. 3 is greater than 2 1/6, and 4 also is. Number 3, just remember if you're going to graph that, you would probably want to switch that around first. Have the variable on the left side is going to be easier for you to graph it. At least for me it is. So opens towards the 2, so that's the same as p is less than 2. So less than 2 doesn't include 2, so open circle. And numbers less than 2 go to the left. And then number 4, they have a graph, and they want us to tell what inequality represents that graph. So we know it's something to do with -3. It includes it. It's a closed circle, so it's or equal to. The question is it greater than or equal to? Is it less than or equal to? Well, it's going towards the left, towards those smaller numbers, so that would be x is less than or equal to -3. So this gives you an idea of how to work with inequalities in their graphs.